Here, hollow disklet, mass of hollow disk, BM. That is, it is related to area, outer circle area minus inner circle area. That is 3 pi r square. For 3 pi r square area, mass is M. For 1 unit, mass will be M by 3 pi r square. But for this ring, 2 pi x dx, mass will be M into 2 pi x dx by 3 pi r square. So the dm is 2/3 mx dx by r square. So this is mass of elementary ring. So now moment of inertia will be integral dmx square, that is from r to 2r. R to 2r, dm is 2/3 mx dx by r square into x square. That is 2m by 3r square, x power 4 by 4 between r and 2r. So what we get here is moment of inertia 2m by small m, 2 small m by 3r square, 15 for per 4 by 4. So here it is 5. What we get is 5m r power 4 by 2. So this is for a elementary disk, hollow disk. Like this, if you consider mini disk, adding all the disk's mass, you get moment of inertia of entire hollow cylinder. Let us say I2 will be 5r per 4 by 2 integral sigma m. Sigma m will be capital M, which is mass of hollow cylinder. So here that is pi into 2r whole square L into volume into density minus pi r square L into rho into density. For that is 3 pi r square L into, this is the mass of here density also 2 times density. Pi r square into 2 rho minus here volume will be mass. How do we calculate? Pi 2r whole square into L minus pi r square L into 2 rho, that is 6 pi r square L rho. So now I2 will be 5r power 4 by 2. M here is 6 pi r square L rho, that is 15 r square. Here it is r square. Here it is r square. R power 4 pi L rho. Right. I will be I1 plus I2, which is 15 pi r power 4 L rho plus pi L r power 4 rho by 2, which is 31 pi r square L rho by. This is moment of inertia. Now, here, I here is moment of inertia, total moment of inertia 31 pi r square L rho by 2. But we have to find moment of inertia I2. I2 will be 15 pi is r power 4. 15 pi r power 4 L rho. So here it is I2 in terms of phi, 15 into 2I by 31, 30I by 31. That is first option is correct. Second option obviously wrong. So regarding masses, M1 pi r square L rho. M2 here is 6 pi r square L rho. M1 is to M2 will be 1 is to 6. So then mass of cylinder will be outer cylinder 6m by 7. So C option is correct. So then capacitor is charged to a potential V naught. So then it is connected to an inductor. So once it is charged and then it is connected, charged capacitor is connected to an inductor. So here discharge happens through inductor such that charge distributes in the capacitor and inductor sinusoidally. So that is nothing but Q is equal to Q naught cos omega t. Because why I am not taking sin omega t at t0, it is already some charge is there in the capacitor. So both are sinusoidal functions. At t0, charge on the capacitor is this. So current will be dq by dt, which is q naught minus sin omega t into omega. I maximum will be q naught omega. And here in LC circuit, maximum current is possible when XL is equal to XC. That is omega L is 1 by omega C. Omega is 1 by root L C. Q naught into 1 by root L C. So Q naught here is 3V naught. So Q naught in place of that, CV naught by root LC. So V naught root C by L. So first option is correct. And potential difference across current, potential difference across capacitor will be V naught cos omega t, which is 0. That is possible when omega t is pi by 2. So omega is 1 by root LC of t. Here is pi by 2. T will be pi by 2 root LC. A given pi root LC, it is wrong. So at t equal to pi by 2 root LC, V becomes 0 in capacitor. That means energy stored in inductor capacitor. Uh, that energy is energy varies among or distribute among capacitor and inductor. So once across capacitor, energy stored is 0, then maximum energy is stored across inductor. That is nothing but half CV naught square. So this is wrong. So D option is correct. Mass M and radius R. So a body of mass small m is orbiting around the planet in a circular path of radius 3r. So effective distance from center of this planet to the body is 3r. So orbital speed he given it as v naught, and E naught is the energy. So once it moves in a circular path, so centripetal force Gmm by 3r whole square is equal to mv square by r. This is force which is equal to m r omega square. R in the sense here it is 3r omega square. So now if planet suddenly shrinks to half of the present radii, but center of mass will not change. So effective distance will be same 3r. So then there is no change in angular velocity. So here, once there is no change in angular velocity, so here v is nothing but orbital speed, so which is root g times root gr, that is 3r. Here there is no change in radius, so orbital speed, no change in orbital speed. Here kinetic energy, total energy will be total energy is minus gmm by 2r, that is 3 times r, when there is no change in effective distance, so no change in total energy. So DC are correct. About D, once orbital speed is same, so A becomes wrong. Kinetic energy will be half m times 3r mv square, 3r or omega square, as there is no change in angular velocity, no change in kinetic energy. So only B and C are correct options. Here, a sphere is rolled on a rough horizontal surface. So since surface is rough, definitely friction will be there. So here, force body is moving in this direction. Force of friction, let us assume that it is in backward direction. So about center of mass, there is a torque. Torque is R cross F. So right, this torque will friction will support rotation. So in angular velocity, it starts rotating means, so angular velocity increases continuously. Right. Once here for translatory motion, friction opposes. So there is a decrease in linear velocity. Once decrease in linear velocity means momentum, there is a decrease in linear momentum. So D option, A option are correct. Here it is, composite cylinder of length L made of two different materials. So here is a cylinder of length L made of two different materials. Two different materials. The inner cylinder radius is R and having uniform density rho, and the outer part is having uniform density 2 rho. The moment of inertia of composite cylinder about an axis, about this axis is I. Then there are four questions based on this. I will be, which is moment of inertia of inner cylinder, outer hollow cylinder. So here for inner cylinder, let us say mass m1, cylinder moment of inertia, everybody knows it, r square. So regarding m1 in terms of density, so it is cylinder volume into density, pi r square L into rho. So here I will write it as this as I1, this as I2. I1 here is pi r square L rho r square by 2, which is pi L r square r power 4 rho by 2. Right. Now about hollow cylinder, before finding uh, moment of inertia of hollow cylinder, first I will find out moment of inertia of a hollow disk, that is mass is here. To find out moment of inertia of a disk, hollow disk. So what I am doing here is I will take some ring, arbitrary ring, which is located at a distance x from the center of hollow disk. So this here moment of uh, what I am trying to find out is inner radius is r, outer radius is 2r, moment of inertia of a hollow disk. So if you take a consider a ring which is at a distance x from it, so its moment of inertia will be dm into x square. So this one, if you consider as a strip, a small, we having a small width dx, its perimeter is 2 pi x dx, area will be 2 pi x dx.